were tasked in creating a device that would detect a burst pipe. This way, flood damage can be less severe since it can be caught earlier on. This product should function for any homeowner. Our project budget was $25 to manufacture and $300 to prototype. The length had to be less than 12 inches and the weight had to be under 2 pounds. The goal of the product was to detect 10 drops of water up to 2 inches of water.
To begin developing a solution, we each brainstormed a unique design and brought it prepared into lab. We then met together and introduced each other's design. Afterwards, we broke into 3 groups and combined any ideas we found interesting to try to make a working product. Being able to bounce off ideas helped us refine our product. This brainstorming process cut us down to 3 viable designs.
Our first design was aptly named the box, which had a pressure plate that the bursted pipe water would weigh down. The next design was the triangle, which implemented a small buoy that would raise up and touch a metal platform as water flooded in, signaling the alarm. Finally was the lightsaber, which was a design that utilized a photoelectric sensor. Once water crossed the sensor's light path, the alarm would trigger. All 3 of these designs were chosen because they had components that were reliable and could be readily made.
To decide upon which design to use, each teammate voted on the 3 designs based on the criteria we deemed the most appropriate. These categories were effectiveness, manufacturability, durability, compatibility, usability, and cost. Here is how we define these terms. Each was designated a percentage value that would determine its importance. From this design matrix, the box gathered the most points.
To help visualize the proposed box, we decided to create CAD sketches through SOLIDWORKS. After considering laser cutting the box, it was deemed too difficult to get done, since we would need precise cuts to slide the main box into the electronics box. Therefore, 3D printing was chosen as our method of fabricating the main component. With the help of the makerspace, we were able to turn our 3D sketch
into reality. Now, we decided upon a simple circuit where the water completes it, signaling the alarm. The wires that would be detecting the water were given aluminum foil attachments to increase surface area. To house the circuit, we 3D printed an attachment that would slide into the main box and keep the electronics away from water. For strapping the box to a pipe, we sewed and bolted belt-like straps onto the main box, which allows for adjustment for different sized pipes. Through trial and error, we chose an efficient design that fulfilled the criteria of our design matrix.
With our fabrication completed, now it was time to test our design. First, we tested if the soldered together circuit worked by submerging the 2 wires in water, which completed the circuit. Next, we did an activation test, which is how long it took for the alarm to go off when exposed to water. The average time was 1.3 seconds. Finally, we performed a sound test where we measured how far we could walk until we stopped hearing the alarm, and our average was 123 feet. It was so loud that a makerspace employee thought it was a fire alarm and he was from a floor up.